Hi, today we're going to work on our temperature and solubility lab from today. We're going to work on, where do my other labs go? We're going to work on the solubility and graph worksheet, and we're going to work on those extra practice problems that we put on page 86 today. So in this lab, literally all we did, or we're going to do, is going to dissolve sodium chloride, which is table salt, sodium chloride, as well as potassium nitrate, were two different white solid substances. We're going to dissolve them both in 10 cubic centimeters of water and 10 grams of each, and see how they dissolved as we increased the temperature of the water. That was the purpose of the lab. But what we're going to use this for is the graph on the back. I apologize if the coloring isn't really dark. Some of the copies came out better than others. Make sure that you read this. That's all important information. But the purpose of this video, I'm just going to talk about these questions. It's important to note the volumes of water. I am going to try to trick you, so this is me warning you to be careful when you read. Do everything mindfully. And pay attention, do everything with effort. So these are out of 100 cubic centimeters of water. So let me describe the graph. So this is a solubility graph. It is showing temperature is our independent variable. And solubility is the function of x, or this is our dependent variable, y. So that's what f of x stands for in your math class. It's a function of x. It's dependent on x. Same thing in science. So our temperature is in degrees Celsius. Our solubility is how much of a substance in grams will dissolve in 100 cubic centimeters of water. And here are 3 different substances on your worksheet. Here we go. What is the mass of sodium chloride in grams that can be dissolved in 100 cubic centimeters of water at 20 degrees Celsius? What we're going to do is we're going to come to our graph the best we can, and we're going to find where 20 degrees is on our Celsius, on our temperature, and we're going to go up until it meets with sodium chloride, and then we're going to take the line over to our Y, and I would call that 39 grams. So sodium chloride will be able to dissolve 39 grams, in 100 cubic centimeters of water. So 39 grams. Now, what is the mass of sodium chloride, again, that will dissolve in 100 cubic centimeters of water, this time at 100 degrees Celsius? Come over to your graph, find about 100, take it up, and we want to know what is this point, the xy coordinates. So we know it's 100 degrees Celsius of temperature, so what is the next coordinate? I'll call it about 42 grams. So this number means that 42 grams of sodium chloride will dissolve in 100 cubic centimeters of water at 100 degrees Celsius. Next, what is the temperature required to dissolve? So now we're looking for temperature to dissolve 200 grams of potassium iodide in 100 cubic centimeters of water. So we're going to find our graph, our substance, potassium iodide. It's this line up here at 200 degrees Celsius, or 220 grams. So we're going to take the line over and see where it matches. It's kind of okay. And then at what temperature is that soluble? So then it'll be about 55 degrees Celsius. That's right. Next is asking, what is the mass of potassium nitrate dissolved? So potassium nitrate, 30 grams of potassium nitrate could fit in 100 cubic centimeters of water at 20 degrees. The question wants to let you know it's heated to 100 degrees Celsius and how many grams must be added to saturate the solution. So how much more do you have to add whenever we increase to 100 degrees Celsius because according to the graph, it's going to increase in solubility, so we'll be able to dissolve more of a substance. But the question's asking how much more will it be able to dissolve. So we need to find our potassium nitrate, which is my yellow line. It says that at 20 degrees Celsius, it will dissolve 30. I'm going to write this over here. It will dissolve 30. That's what it says. So even if the graph's not that good, it says it right there. At 20 degrees Celsius. Then if we increase the temperature, we go this way, we can see the potassium nitrate increases. So we need to find 100 degrees Celsius, which was over here, and how much would dissolve in it. I'd say about 240 grams. But if we only put 30 in it at the beginning, when it was 20 degrees Celsius, how much more would we have to put in it when we heat it up to 100 degrees Celsius? And that answer is the difference between these. It is going to be the 240 grams minus the starting 30 grams would be, you need to add 210 grams more. And that's that worksheet. Here is our solubility graphs. Again, we have temperature, and our solubility is a function of temperature for these different substances, and we need to check our labels. And this is a gram of the salt in 100 grams of water. So again, we have our volume of 100 cubic centimeters of water. For questions 1 through 4, an amount of solute is given, the salt, and the temperature is stated. If all of the solute could be dissolved in 100 grams of water at the given temperature, will the resulting solution be unsaturated, which is dilute, saturated, or supersaturated? Here we go. So we have potassium chloride, KCl, at 70 degrees. So how much potassium chloride will dissolve in water at 70 degrees Celsius? So we find 70 degrees. Here's our line, the KCl, and take it to it. So from here, we need to now figure out, well, what's the solubility of this KCl at our temperature? Take it over that way. So it could hold about 45 grams for every 100 cubic centimeters. So if I only put in 60, it can hold 45, so is it unsaturated, supersaturated, or saturated? And of course it will be supersaturated because it will only hold 45, but I'm putting 60 in. So how much would fall out of solution if you were to put in 60? You can find that by 60 minus 45, because that's what you added. This is how much it'll hold, so 15 grams would fall out of solution. Next we have KClO3. ClO3, that's this line. So what is the solubility at 60 degrees Celsius? Go to 60, take it up, and take it over. I would say it would hold about 25, let's say 25 grams for every 100 cubic centimeters. If I put in 10 and it only holds, it holds 25, it's going to be unsaturated because it can hold 25, but I'm only putting in 10. It would be able to absorb about 15 more. Next is we have NaNO3. That's this line all the way up here. So at 10 degrees Celsius. So it looks like it holds 80 grams for every 100 cubic centimeters. So if I put in 80, it can hold 80. It is saturated. No more, no less. Next we have CaCl2. That's this curved line at 20 degrees Celsius. it looks like it'll hold about 75 grams for every 100 cubic centimeters. So if it holds 75, I only put in 70. It's going to be unsaturated, and it can hold up to 5 more grams. For questions 5 through 8, a solute, the salt, and the temperature are given. Our task is to tell how many grams of the solute must be added to 100 grams of water to form a saturated solution at the given temperature. So if we have PbNO3 2, that's this line, at 10 degrees, how much PbNO3 2 will dissolve in that water at 10 degrees? So come to 10, go up, take it over, and I would say about 45 grams of PbNO3 will be able to dissolve in 100 cubic centimeters of water at 10 degrees Celsius. Next, we have Ce2SO4 at 50 degrees Celsius. That's this. Hopefully you notice that this is a gas because as the temperature increases, the solubility decreases. So at 50 degrees Celsius, it looks like it's about at 5 grams. So 5 grams of this gas will be soluble in 100 grams of water at 50 degrees Celsius. Next, we have sodium chloride at 20 degrees Celsius. Sodium chloride on our graph is this line. Nope, I'm sorry. It's this line. Sodium chloride. And we're looking at 20 degrees. So 20 degrees, and take it over, it's about 35 grams. So 35 grams of salt will dissolve in 100 grams of water at 20 degrees Celsius. Finally, we have K2Cr2O7 at 50 degrees Celsius. That's this line at 50 degrees Celsius. Looks to be about 30 grams. We're going to skip these. So if 115 grams of KNO3 are added to 100 grams of water at 35 degrees Celsius, how much would not dissolve? So how much extra was put in the solution and will precipitate out? So we need to figure out what is the solubility of KNO3 at 35 degrees Celsius. Come to your graph. Here's 35. KNO3 is up here. Here. So I'd say it's about 55 grams for every 100 cubic centimeters. So if it only holds 55 grams for every 100 grams of water, and I'm putting in 115, how much extra did you put in? You would take 115 grams minus the 55 grams that it holds, and then you would be left with 60 grams at the bottom of your test tube. So if this was your solution, it would be saturated, and you would see 60 grams of stuff in the bottom of that test tube. Finally, what is the mass of potassium chloride would be needed to form a saturated solution if it was dissolved in 200 grams of water at 80 degrees Celsius? So KCl is this line. We're at 80 degrees. It looks to be at 52 grams for every 100 cubic centimeters. But remember, the question is asking now about 200 cubic centimeters. So what is the mass in grams that would be able to dissolve in 200 cubic centimeters? It would be 104. 104 grams. I'm going to give you some bonus questions. Thank you for being patient and taking ownership of your learning. I'm really proud of you. So this is our graph we put on 86. It doesn't look super good. My apologies. And here are some bonus questions. Go ahead and pause it right here and write down those questions. For the sake of time, just hit pause. I'm going to move on. Here's your graph. Number 1, how much KNO3, so this graph, how much will precipitate out of solution if the temperature changes from 70 to 50 degrees Celsius? So remember, we're over here. So at 70 degrees, at 70 degrees, 130 grams of KNO3 will be able to dissolve in 100 cubic centimeters of water. But if we were to cool it and go that way, how much would precipitate out of solution? Well, now we need to find the solubility of our substance at 50 degrees. It'll only hold 80. So the difference of how much extra will fall out of solution would be the difference between the two, or 50 grams. The next question asks, what volume of water is needed to dissolve 35 grams of the same substance at 45 degrees Celsius? So if you come to the temperature, we need to find 45 and see, well, how much of our substance will dissolve. So come to 45, you would take it up to where it meets, and how much stuff is going to dissolve? 70. Well, that is 70 grams and 100 cubic centimeters of water. But the question asked how much water would be needed to dissolve 35 grams. So what would that volume be? It's a proportion. So whatever you do to 70 to get to 35, divide by 2, you would do the same to the bottom. So the volume of water that you would need would be 50 cubic centimeters of water to dissolve 35 grams of KNO3 at 45 degrees Celsius. Go ahead and add that down here. Alrighty, thank you guys. Have a good day.